All right. Good evening, everybody. Bonne soirée tout le monde. Bienvenue dans ce meeting de Data Platform ce soir. Ce soir, on a la chance d'avoir Michelle Goodzeit. Elle va nous présenter sur comment sauver de l'argent sur nos licences SQL Server, puis comment on peut consolider. So, Michelle, you're going to present tonight on the SQL Server license cost. So, you're going to make us rich tonight.
Yes, everybody's going to be very rich. Thank you,
All right.
Christian.
So, Michelle, you're on.
Yes, I'm on. Okay, so I'm not sure if you want to make my presentation. So can you still see me or just
No,
the slides? Just the
no.
slide, okay. So I guess everybody already knows me. I'm one of the co-organizers with Christian. Well, you left me on camera, so all good. So I decided to have this presentation because a lot of my clients in the past have asked, how can we save license costs? SQL Server Enterprise Edition is becoming very expensive, and what can we do? We have too many SQL servers. What can we do? So I just decided to create this presentation, and this is not only about consolidation. This is about the common ways to save on license cost, and then the uncommon ones. So I'm going to do some fun presentation today. So for those of you who don't know me, my name is Michelle Goodzeit. I'm a Microsoft Data Platform MVP, and I work at a company called EPAM. I just moved recently 2 weeks ago, and I'm still learning what they do. It's a company that provides many services around analytics and reporting and data migrations to the cloud, mainly modernizing applications and databases. So let's start. I'm moving to my screen. So let's start. So what am I talking about today? And feel free to write comments or if you have questions or if you have comments. And Christian, feel free to intervene if anybody has a question. And
Yes,
just
I
let me
will.
know because I see, I see my screen with the presentation and I don't see the chat.
No
Okay.
problem. Yep.
So let's talk about your potential current architecture. So what are you working with in terms of your SQL Server environments and maybe other databases? So it really depending where you work, I'm going to talk about the potential current architecture. I'm going to talk about the benefits and drawbacks of the consolidation. I'm going to talk about the options to consolidate. Like I said, the ones that are most common when we're talking about consolidation, and the ones that are like the less common thinking. So this presentation is about widening the point of view around modernizing and saving costs, not only consolidation. I'm going to compare between the solutions as much as we can. I'm going to talk about, okay, so we have decided to consolidate or to do something to reduce the license cost. Where do we start? I'm going to talk about some free tools that can help us in the process or project of migration project. So let's talk first about our current architecture. And like I said, it really depends where you work. You may be working at a very small company, or you may be working at a very large company. So let's talk about the worst case scenario. Let's assume that you have a lot of SQL Server environments. And the problem with the big organizations is that as time passes, so we're probably, there are some organizations that are already there for 20, 25 years, and building in-house applications or buying third-party. And usually what we used to do is just create instances, create servers on-prem in data centers. So every time we have a new application or a new development, a new vendor, we just add and add and add instances and servers. So eventually we end up with a lot of servers, a lot of database servers. And it could be that everything is in one data center, or it could be that we have a lot of data centers. And we can even have data centers in different countries. We also, it may be the case that you have dependencies between databases, between instances, or even remote instances. So in some cases, you will have a very, very complicated environment where you, when you think about consolidation, you need to think about all the dependencies, because you cannot just move something to another data center or to the cloud or consolidate. You need to understand the dependencies and your current architecture. Let's complicate this a little bit more. You may have different sizes of environment. You may have instances with a lot of databases, medium size and small size, and you may even have different editions of SQL Server, Enterprise Standard, Express, Dev, Development, whatever you have in there. It could be a web edition. So you have a lot of different types of editions, and maybe even different versions of SQL Server. Maybe you even have, hopefully, I did not put SQL Server 2000. I'm hoping that nobody has SQL Server 2000, but potentially you also have the older versions, and potentially you have a lot of environments with different level of service packs and cumulative updates. And by the way, the SQL Server 2020 is just a bad joke about the COVID. So we don't have that yet. So just a little joke for me. So very complicated environment. We may have physical servers. We may have virtual servers. We may have virtual servers in the cloud already, in any cloud. Or we may have databases in the cloud. So your environment may be a lot more complicated than, than just very complicated to manage, very complicated to even think about consolidation. So let's discuss further. And to even complicate more, you may have more than one instance installed on a server, either a physical server or any VM, either in the cloud or on-prem. So how do we manage that, right? We have many instances in one location, in one server. So that could be your case. And I really like this slide by Microsoft. We need to remember that SQL Server can reside anywhere. And from the application perspective, we are connecting to a database or to an instance. And it doesn't matter where the instance resides. If you look down here in this slide, you can see that you can have on-prem hardware with operating system and SQL Server on a physical machine. Or you can have a host hosting virtual machines with SQL Server instances on them. Or we can have in the cloud, so the blue in the cloud, a VM in the cloud with SQL Server installed. Or we can have a database in the cloud, just a database, which is platform as a service. Or we can have software as a service where everything is managed for us. So as we go down here, it's more in our control. So we manage the hardware. Every time we need to scale out or scale up, we need to add hardware resources. It's a lot of things that we need to do. We need to probably buy hardware, purchase new hardware. We have to install everything on it, up to the operating system, and on top of this, the SQL Server. Think about the applications. So that's a lot of management, but everything is in our control. Okay, so we need a team, we need the different teams that manage for us, manage those environments. As we go up, we have the virtual machine. So we still have the host to manage the hardware, but we do have virtual environments. So it's a little bit more flexible because we can move virtual machines from one host to the other. We can allocate resources differently. So another way to have a lot of maintenance. As we go to the cloud, we no longer have to manage the hardware resources. So we just get an operating system and with SQL Server, and we only have to manage that. So the operating system and app. If we have a database in the cloud, this is the only thing that we need to manage, the database in the cloud. We don't care about the hardware. We can add resources, and this is in the cloud. So somebody else is managing, somebody else is patching for us, somebody else is managing, the backups are being managed for us, and so forth. So the more we go higher here, the less work we have for us. Okay, everything is being managed for us. And from the application perspective, it's just a database. So we connect to the database and we have the data in there. When we talk about consolidation, so SQL Server and SQL Server database can reside anywhere, but we also need to think, when we were thinking about consolidation, we need to understand how the network is set, or what are the network requirements. For example, do we need specific security on the network? Do we need some devices to be disconnected from the public network, some devices that can be open to the internet? So we need to understand what we have around the SQL Server environment. Okay, what is the type of configuration that we need on the network? We need to think about security. So do we have like environments that are a lot more secured? Do we have environments that are more open to the public? For example, like the website, everybody can view our website. And so it's okay, it's a different type of security. So what is the security level? Another thing that we need to think about is the legacy application. So what if, for example, we have a very, very old system where the application server and the database server, or the application needs to reside where the database server is. So can we separate between them? If we want to consolidate that database or database server, are we actually able to disconnect from the application? So this is a big thing. What are we doing with the legacy applications? And what happened, for example, if you purchase a third-party application and the vendor insists that we cannot consolidate the databases of that specific application, because then we don't have support. So we know that from security perspective, from network perspective, from any other perspective, we can save on licenses, but the vendor insisted that we are not going to get support for them. And therefore, the instance or even the server need to be separated from the others. And what happens if, for example, we have a very old application where the development team is no longer there, either the in-house development team or from a vendor? What are we doing there? So we probably have applications where we are being told, don't touch, because we don't know how to modify the connection string of the application. We don't know anything about this application. It works. Don't touch. So we need to know about those that cannot, unfortunately, be consolidated. Or maybe yes, we need to make a research about that. Let's talk a little bit about the benefits and the drawbacks of the consolidation. So as you can see, some of them are benefits and drawbacks as well. So let's see. So the first one is that one of the benefits is obviously when you consolidate, you have less environments to manage. So any way of consolidating, you have less. But the drawback is that potentially you will have performance degradation and higher maintenance efforts, because you will need to allocate resources. So if you consolidate a lot of things into, let's say, one server or one instance, you will have to make sure that the databases or whatever you consolidated do not fight over resources. So you need to think about segregation. So you may have you may have less cost around the hardware or the machine, but you will have maybe more efforts around maintenance and segregation. Another benefit is that obviously if we consolidate, we may be able to lower the license costs from the operating system and maybe from SQL Server perspective as well. But it could be potentially more complex security setup, right? Because if we need some segregation, we don't want, so for example, we have something, a system that is taking care of credit cards, and we don't want users from another system on the same server to be able to read this information, because we need security segregation. Another benefit is that we can potentially lower the hardware costs. And I'm saying potentially, it's really it really depends on how we consolidate and what we consolidate. Sometimes we need to make sure that when we consolidate, we're actually reducing the costs, right? Because let's say that you have, you're consolidating environments and you need to purchase bigger hardware, then you may not be resolving anything. You may introducing more problems to your environment. On the drawback side, the consolidation effort itself may be very high. So if we need to move, for example, databases, or we have to move instances, what does it cost us from the application perspective? Do we know how to change the connection string? Do we know how much time it takes? Is it easy? We have to talk about the downtime and stuff like that. So another benefit is that we may require to upgrade versions of the operating system and SQL Server if we're consolidating environment that require the same version and maybe addition of the operating system or the database server. And we need to think about the compatibility level. For example, if we are taking very, very old database that cannot change the compatibility level, we need to make sure that it's feasible to move this database with older compatibility level to a newer SQL Server instance. So it's a benefit, but it's also a drawback. So what is the effort required for us to be upgrading versions of the operating system or SQL Server? Do we need to do a lot of testing? Can we leave the database in compatibility level? And the last benefit in this slide is that we potentially, when we consolidate, potentially we can reduce the size of the team that is supporting the environment. Okay, so if we add a lot of servers and a lot of operating systems and a lot of databases, we can reduce the cost of that team and maybe allocate this team to do something else. But it could be a drawback for you, because if we are reducing the size of the team, we may get fired. So we don't want that. So it may be a drawback. And a lot of times I see that, like DBAs or sysadmins, they're against consolidation because they're actually afraid to get fired. So we need to make sure that this is not us, right? Or that we are allocated to another type of work, maybe. So let's talk about the consolidation options. I'm going to talk about the conventional ones, and then I'm going to talk about non-conventional ones. And like I said at the beginning of the presentation, it's just to open our eyes like wider. You probably already know what I'm talking about, but it will give you some idea. Sometimes somebody talks about something that you already know and you say, aha, you have an aha moment. So this is what I'm trying to do here. Let's talk about the conventional ones. The conventional ones, the first one is virtualization. So let's assume that you have virtual environments, and as you can see in this diagram, we have 3 servers or 3 hosts, and one of them is hosting 4 VMs, and you have 2 other VMs on different machines. So physical server A and physical server C, if they're not very busy, if you have enough resources on physical server B, you can consolidate the VMs into physical server B and use A and C for other purposes. So this is the first one to consolidate. We need to make sure that we have enough resources on physical server B to host the 6 machines. Another type of consolidation, let's assume on the left we have 4 servers with 1 instance on each. But what happens if we have another server that is free, could be physical server, and we can just move those instances into 1 server and just let them live all together on 1 physical box and get rid of the other 4 servers. So as you can see, we can have less maintenance. Maybe we can have different type of licensing model, but we are introducing a little bit more. We'll talk about the differences But this is the basic of the solution. The next solution is, let's assume that we have multiple databases on 2 instances, and if they are, let's say that one of them is Enterprise Edition and the other one is Standard Edition, or both of them are Enterprise Edition, if we just do something like this and we move the databases from one to the other, we can get rid of one of them. So this is an example of database consolidation, and we're introducing maybe more performance load on that instance, but we may gain. If the previous one was Standard Edition and now we're moving the databases to Enterprise Edition, we can gain a lot by just doing that, because we can start using the features of the Enterprise Edition. So this is just an option, just an example. And the last one in the conventional consolidation methods is, assume that you have a single DB per client. So just from an example from a real client, they started small. So what they did is that they created a database per client. They started with 10 clients. So they had the database per client, and then every time the application had a version upgrade, they just had to manage 10 clients, and it was easy. But then they started growing and growing and growing. And when they came and asked for assistance, they had 20,000 clients. So what they ended up with was 20,000 databases across many instances. And every time they had a new client, they had to think, where do we place this client? Which instance or which server can host another client? And they had to understand, what is the client going to be? Is it going to be a huge client? Is it going to be a small client? Are they going to have a lot of activity? And it was very hard to estimate. And also all the maintenance and version control, it became a big monster. So what they decided to do, and fortunately, they were smart enough at the beginning, and they added the client ID to each of the tables. So it was easy to consolidate multiple clients into one database and make it a multi-tenant database. Okay, so they did not consolidate the entire 20,000 databases into one, but they knew more or less based on the size which databases they could consolidate, and then everything became less, more maintainable. So it was easier to maintain, easier to add smaller clients to the same database, move databases from one server, one instance to the other. And this is just one example. So another way to consolidate multiple databases into one database is, let's say that you have different schema in those databases. You can always create a schema in a database, right? A schema, and then move tables into that schema. This type of consolidation requires a lot of planning, okay? But it may be suitable for some of your applications or some of your scenarios. So it really depends. And let's talk about the more options. So I'm going to talk about the options, and you will see how it makes sense when we're thinking about consolidation or reducing the cost. Those things will start making sense, and you probably already know about those things. Let's talk about them. So the first one, obviously, we have the cloud, the database in the cloud. So we have Azure database or RDS, either SQL Server or another platform. So it's just a database in the cloud, right? So this implementation is not good for every database. So for example, some applications will require more than one database in the application. And this is not a good implementation if the databases need to talk to each other within the database. So for example, if you use 3 parts names, this is not a good implementation. You will need to modify the application to connect to each database separately, okay? This is good when your database is totally independent from other databases. Okay, so you just move the database to the cloud and you don't have to manage anything. The provider is taking care of your patches. You don't need to understand the hardware behind it. They just tell you how well it will perform instead of you know, the CPU in terms of IOPS. So you know how it will perform, and you don't have to take care of anything except for your database. So Microsoft themselves, they said, if we think about the database in the cloud, when you create a database like that in Azure Database, for example, or RDS, you have to decide what is the performance that you will need and what is the size that you will need. And this is what you're paying for. Okay, so you either pay for 1 year or 2 years, or you pay monthly, but this is the size that you got. Microsoft came up with a different solution that helps in some scenarios. So imagine that you can allocate resources to a group of Azure databases. So you group them all together and you say, okay, these are the resources that I'm allocating to them. And then you group all the databases. This is a good scenario when you have, for example, the databases don't have the same type of load. So one database, the load is high during the night. Another database is the load is high during the morning of the same time zone. So you can just drop all the databases under the same resource umbrella, and you don't have to pay for all the resources for each database. So by that, you can save on costs, and you have 3 layers. You have the basic, the standard, and the premium. And you can move databases outside of a pool and inside of a pool easily based on your need. So this is something that can help us when we talk about saving and consolidating. Another thing that Microsoft have is the managed instance on Azure. So it's still a PaaS solution, meaning that Microsoft is taking care of the patching, the hardware, the operating system. So you just have an instance in the cloud. You cannot do anything related to the operating system. So a lot of the features, not a lot of the features, but some of the features are not going to be allowed with Azure managed instances. And you still have some constraints. For example, you can only have 100 databases. For example, there's a specific size to that instance. So if you have a large data warehouse with few databases, maybe this is not the right solution for you. You need to look at the constraints. I think that managed instance, it's 4 terabyte per database. I don't remember exactly, but Microsoft and all the cloud vendors keep changing all those things. So when you decide to move to something like that, like managed instance, you need to look at the constraints and make sure that those constraints you're still good when you're moving to that specific type of model in the cloud. So that's the managed instances. And like I said, if you look at the documentation, Microsoft tells you exactly which features are not going to be supported with managed instance. Usually those are things that are more related to the operating system and the underlying hardware or underlying, the Windows or the anything under the instance. Another thing that we need to remember, and I'm not sure, maybe some of you already have worked with contained and partially contained databases. A contained database is a database that is independent from the instance. So it can be on-prem, and the entire security model is disconnected from the instance, because, for example, when you have a SQL Server instance, you have the login, and then you have the user in the database. But first you log into the instance, and then you have to, either by default, or you have your database where you have to go to that database and do things, right? So contained database is the ability to connect directly to the database without going through the instance. So it's just a database. So for me, it's like having a database in the cloud. The database is a separate unit, and it's portable, right? It's portable, it's isolated. And the beauty is that you can even have availability groups. This database can be part of availability groups and fail over as a database, okay? So you can have, like, you can administer this database without being a sysadmin. So this is a very strong thing to do. And the database can have its own collision, and it's working fine. The drawbacks is that some features will not work. For example, replication, CDC, change tracking, and numbered procedures. I haven't seen a lot of implementation with numbered procedures. The partially contained database is still the same as the contained database, but the partially contained still has code that is touching the instance or touching the operating system. Okay, but they're still contained, they can still be portable, but when we port this type of databases, we need to make sure that when we port them, they're still going to work the same, because they still touch objects that are not just the database. And they're treated the same, both of them. Let's talk about SQL Server on containers. This is I know that we had a presentation like that by Edwin. That was a year ago, or maybe a little bit more. So let's not forget that we can place SQL Server on containers. So the difference between, you can see here in the diagram, the difference between virtual machine and containers is that on both sides, we still have the infrastructure, we still have the host operating system, but we have a layer. So on the VM side, we have the hypervisor, but on top of that, we still have the guest OS, and we still have the binaries of SQL Server on top of that. So we have a VM with SQL Server installed. When we're talking about containers, we do not have the guest OS. So it's a Docker engine, and on top of that, we have the binaries. So this is a very nice thing. Why? Because we can separate the compute from the storage. So basically, you need to make sure that you have high availability in DR for your storage. But if any of those containers have a problem, you can always spin up a new one very fast. So you create them very fast, you spin up very fast, and you save on the license cost of the guest operating system. And of course, the containers are available on Linux, Windows, and Mac OS, while VMs, now we can place SQL Server on Linux. And it works in Azure and AWS environments, so you can be cloud agnostic, so either on-prem or in a cloud environment. So this is a SQL Server on containers. Microsoft also introduced serverless Azure SQL database. So when I talked about Azure database, we have an Azure database, and we have to allocate resources, right? So we have to say, okay, this is the layer that we need for this one. This is the IOPS that we will need. This is the amount of RAM. This is the amount of CPU. But what if you have a database that is only active X amount of minutes per day, or X amount of hours per week or per month? Why would you pay for resources? So one way would be to put it into Elastic Pool, but maybe even that solution is not good enough. Maybe that you're just wasting resources. So Microsoft came up with the serverless Azure SQL database, which is you just have a database, and you pay for what you're using. So let's say that you have while the database is inactive, you're not paying for the usage. When you need to run something in the database, maybe once, like I said, once a day, or once a week, or once a month, then you pay for what you use. It's fully managed. It's a PaaS solution. It has 4 nines availabilities, and it's good for some of the implementations. So that's another thing to think about. And of course, we can place SQL Server on Linux. If you love Linux, you can benefit a lot from moving to Linux. So one of the things is because Windows is known to be a little bit more heavier than Linux. Linux is lighter. So if you look at the top popular sites that do TPCH benchmark, you will see that SQL Server on Linux is at the top. Why? Because it doesn't have the all the heavy stuff that Windows have, and also you have the same features, but you don't have to pay for the Windows license costs. So when I tell this to my clients, they say, listen, most of my costs are for the SQL Server. For example, SQL Server Enterprise. If you compare SQL Server Enterprise Edition and Windows Enterprise Edition, then the SQL Server wins, right? It's much more expensive. But still, if you have a lot of Windows servers, you can still go to Linux. You have better performance, and you don't have to pay for the Windows. And there will be a lot of clients that would like to move to the open source databases to save on license costs. But SQL Server has more features than most competitors. So it really depends on the implementation. If you look at Postgres, if you look at MySQL, they don't have the same capabilities as SQL Server. So when you need to decide where to go, like you obviously you can decide to go to Postgres or MySQL or another open source, but you need to look at your application, the needs that you have, and what you have inside the databases. Some of the more modern application maybe will use the database just for a database, just for the schema and the data, but some of the application will heavily need the database features. So this is another thing to think about. And here's another one. So data lakes. So the new DBA, okay, the modern DBA, in my opinion, needs to understand the entire data stack. So it's not only about SQL Server and also developers. It's not only the SQL Server and the database. So we have OLTP, we have data warehouse, and we also have data lakes. So imagine that we've been working for years on applications. We've been gathering data. Most likely, if you are working at the startup, then maybe you don't have a lot of data, but you also need to think about the future and what's your growth rate, okay? So we're accumulating data like crazy, and eventually, and this we see where when the clients have been working for a long time and accumulating data, eventually you have to think about the future and what am I doing with all this data, right? So let's say you have an OLTP, but all of a sudden eventually you will need to do some analysis on this data or archive this data or whatever. You need to do something with this data. Some of the organizations will need to keep the data for, let's say, 7 years or 10 years, just in case they're being audited, right? So we do have other solutions that are much cheaper than keeping a relational database, right? You can use AWS S3 buckets, which is a blob storage, to keep your data. So both on AWS and Azure Data Blob Storage Generation 2, you can place data in files, for example, in Parquet files, which is very compressed in JSON, as CSVs, and just place them there. This data is usually read-only data, historical data that you just need in case. And there are tools where you can either read the data and the performance is not going to be great, but the data is there. So in many implementations, we just need, in many environments, we just need the data to be there just in case, or you know, every once in a while we need to go back to the archive and grab some data, but we don't care about performance. So think about archiving or placing data on blob storage. Now, for the future, if you need to do something with this data, for example, for analytics, you can always use you know, the analytics tools. For example, you can use Athena on AWS, you can use the Synapse or Databricks on the SQL on the Azure side, okay? And you can even query this data that is on the blob storage. You can query from your on-prem or from another SQL Server using Polybase and external tables. or linked servers with AWS and Athena, or with Azure Synapse. So all the cloud providers are saying, okay, listen, we're giving a cheap solution to save the data. You start with that, and then you decide how to query it, either by analytic tools or by your OLTP. You can still do that. So it's going to be seamlessly. Maybe the performance is not going to be great, but you will still be able to query this data. So this is another way to cut on costs. Let's try to compare the solutions. Now, we're trying to compare between apples and oranges, obviously, in many cases. As you can see, we cannot say, okay, this solution, for some implementation, we cannot decide on a specific implementation. And it may be that your environment is so complicated that you will decide to consolidate or to save on costs in different ways for different applications. You may even be, like cloud agnostic. So, for example, you can go and do things in Azure and do other things in AWS or Google based on what you need. Okay, so it doesn't mean that you have to put everything in a specific cloud. Let's just see. So there's a lot of things that we need to think about when we're comparing between the solution, and this is just an example. And really, the answer for you and the decision has to be made for your specific environment, for your specific applications. So this is just an example. This slide, I'm comparing between on-prem virtualization versus instance versus database. So the first one is virtualization. So consolidating operating system into the same host. So many VMs into a host. Then we have the instance consolidation. So we're consolidating, we're moving few instances on the same OS. And we have the last one, which is the database consolidation, moving databases from instance to instance to have one instance with more databases. Okay, so those are the solutions that I talked about at the beginning. And I've decided to create those topics. So from a management perspective, from HANDR, from security, from performance, from license cost perspective, from hardware cost, and total cost. When we're talking about the total cost, we need to this is very, very hard. What are you paying now versus what you're going to pay at the end versus what are you going to pay for that consolidation project, okay? So I'm going to talk about that. Let's take just an example. In terms of security, when we're talking about virtualization, the machines are isolated. So we have one host and we're starting to accumulate more VMs on the same host. So the machines are actually, from security perspective, are totally isolated. We don't have a problem. When we consolidate instances into the same OS, the instances themselves are isolated, but they still have access to the OS. So we need to talk from security perspective. We need to think about what if we're able to touch the file system? How are we segregating the file system or any operating system type of things that we can touch? So we need to think from security perspective about that. What happens when we consolidate a lot of databases under the same instance? Again, from security perspective, it's even worse, could be worse, because we need to segregate the databases and isolate the databases, right? So the databases and the OS. So this is just an example. What about performance? Okay, it's when we're consolidating VMs on the same host, we may get lesser performance, like performance degradation, but it's it's easier to manage. Like you can move VMs from one host to the other, or you can allocate resources based on the need on the VM, on the host, right, for the VMs. When we're consolidating instances, then we will need to make sure that we're using, for example, resource governor to make sure that each instance is not actually taking resources from the other instances. So if, for example, we're consolidating an instance that is more critical than the others, it has to be, we have to make sure that the resources are allocated appropriately. And when we're talking about databases, same, we don't want to have like one databases using all the resources and killing the other databases. So this is, again, just an example. And when we're talking about the total cost, again, we need to think about the team that is managing the environment. Are we going to save costs there? Not only from license costs and hardware costs. What about the team? What about the management? Do we have less effort around the management or more effort? So as you can see, it really depends. It's not like we say, okay, if we do this, this is the right thing to do. It really depends on what you're trying to consolidate or what you're trying to do. Let's show another example, which is on-prem versus the cloud. So the same topics, and maybe you have different topics. Maybe my thinking about the topics is not good for your environment. Maybe you don't care about high availability disaster recovery. So you do your own homework on your own environment. Let's talk about, for example, on-prem versus the cloud. So manageability. When we have an on-prem, either a physical or VM, we have to manage the hardware and VM. We have to manage everything on top of it. So it's more management for us. If we need more hardware, it means we need to buy more hardware and start managing the physical versus VMs. So it's a lot of management, right? On cloud VM, for example, in IaaS, so we have a VM in the cloud, meaning that the entire hardware layer, meaning networks and stuff like that, we still have to configure the networks, right, depending what we're doing. If we have a hybrid environment where we have partially, like some of the applications and databases on-prem, still have network, but from the cloud perspective, we only have to take care of the operating system and the instance, and that's it. We don't have to manage the hardware. We want to move to a bigger machine, that's fine. Sometimes we can scale up within the same tier, depending on the cloud, or we have to do a migration, but it's from the same cloud to the same cloud. So that type of migration is easier. We don't have to manage any hardware. We don't have to buy any hardware. We can spin up machines in the cloud very fast. And on the same topic, manageability, when we're talking about the paths, so we just have a database. We have a database in the cloud, and this is the only thing that we need to manage. So we need to manage, what do we need to manage? The performance, probably, the logical, but not more than that. We don't have to manage the hardware and the operating system. So this is another example. Let's talk about the last example, which is virtual versus the containers. So from, and again, don't take my word on it. I'm going to talk about what's next, but those are like general concepts and general comparison, but you still need to verify that those are true to your environment. So from license cost, for example, here, you can license by processor, depending which, what is the provider, who's the provider. And on the container, you will have less OS licenses, like I said, but still each instance of SQL Server still needs to be licensed. So are we saving this versus this? Are we saving on the OS license cost? What do we do? The hardware will be the same, but the total cost of containers will probably be cheaper. And again, don't take my word on it. You need to do some legwork in your environment and make sure that this is the right solution for you. So I hope I made my point. So now you're probably thinking about your environment. I have this application and this application and this environment and this environment. Where do I start? So in some environment, where to start is even complicated. So what I suggest is to have like some kind of a checklist. And let's see, because I've dealt with a very complicated environment where the client had hundreds and hundreds of SQL servers. and different departments. So the first thing that I had to do with that client is inventory. They didn't even know, because what they had like a central IT, and they had a lot of departments. So they didn't even know the inventory. So that was the first step. Inventory your instances, your application databases and owners, and also the dependency between the applications. How do you do that? It's very complicated. There are tools that do that. For example, based on users, okay? But sometimes it's very hard to, when you do make a diagram of everything that you have, it's very hard to see the actual relationships, okay? Like I said, there are tools that can do that for you. Even Microsoft has tools that maybe those tools are not 100%, but can give you an idea, okay? So first thing, inventory what you have. Then group the environments by SLAs, critical, less critical, how much downtime can you allow, what's the high availability disaster recovery that you will need, the backup frequency, stuff like that for each one of the environments. Review the current capacity and performance of the environment. So when we're talking about consolidation, we need to understand which machines are on their knees, and you cannot just add databases or add instances to that specific machine, or you need to buy a bigger machine. So you need to understand how your machines and SQL Server are really performing. So now, many times you will think that you have performance issues, but you actually have configuration issues. For example, if you're not maxing up your SQL Server memory, and SQL Server is eating too much memory and the server is on its knees, it doesn't mean that you have performance issues. So you need to look at things based on what they really are. So there are tools that can help you with capacity and performance, and make sure that you actually know what you have and what you need. Review the isolation requirements and security. So like I said at the beginning, in some cases you need to isolate the environment, not only for security reasons, for if it's a vendor that requires isolation, because otherwise you don't get support. They don't want to consolidate with other applications or other databases. Sorry for my French. So you need to understand the isolation requirements. Review the dependencies. This is very important. In some consolidation projects, there were some hidden dependencies. So if you're using link servers, replication, anything that can give you a hint about the dependencies between databases and instances, you need to try and catch those, because otherwise you will have to move. Sometimes you have to move like a group of databases or a group of instances altogether because of those dependencies. You need to know that. Try to assess the current cost, but when we're trying to assess the current cost, it means everything, like the team that is supporting, the electricity on-prem, if your environment is on-prem, how much are you paying for the current hardware? How much is left in your contract for this hardware? Maybe it's not a good idea to move now because you already paid for your hardware. What does it mean? So what do you have right now? How much do you pay for how long? Okay. Try to assess the future budget. So what are we trying to achieve? Okay. Do we actually want to cut costs? Where do we need to cut costs? How much do we need to cut costs? And let's try to stay within our budget. Discuss the costs with the vendors and representatives. So let's say that you're using Microsoft and you have an enterprise agreement with Microsoft. You need to understand what will be how it will affect your budget to move from on-prem, for example, to Azure or to another cloud. Okay, or you have to discuss with the other cloud provider how much it will cost you to move from one type of platform to another. You need to understand more or less what it will mean for you, or if they can give you better prices than the market prices. Okay, and also the vendors, how much would it cost me for you to support my move? Okay, Assess the upgrade feasibility if required. So hopefully you don't have SQL Server 2000 or 2005 that are no longer, and 2008 that are no longer supported, and SQL Server 2012 will soon not be supported. So this is a good time to try and move to better, to higher versions. And really, this really depends on your application and your ability to test applications against the newer hardware. But you need to understand what are the versions that you have and which applications you can actually upgrade. Assess the feasibility of the consolidation options or anything else that we've talked about today. So what is the best solution for this database or this instance or this server, as we're thinking about modernization or saving costs. Estimate the cost of the consolidation project. So what we need to do is this. This is our current cost. This is where we want to go. Okay, this is how much it will cost us to be there. So in how much time are we going to be even? So we have the initial cost and the target cost and how much it will cost us. So when are we going to start to be even? So if, for example, in 5 years, your future costs are going to be the same as current costs plus the consolidation project, or less than the initial one, then it's good to consolidate. So you need to know in how long you're going to be start paying less or manage less or whatever is your goal. It's not necessarily going to be the cost. You know, your goal could be, your reason for moving could be to get rid of a data center, to get rid of a building, stuff like that. It doesn't mean that it's always like the budget is what drives you. And this is also important. By the way, I would add it to the checklist. What's your goal? What's driving you? And like I said, estimate the cost over time and compare. So this is like a checklist. This is my checklist. You may have a different checklist. You may want to send me comments. I am always eager to learn. If you have additional things that you think I should add to that list, I would be happy to learn. So let's talk about the strategy. So create a consolidation strategy, methodology, and plan. Okay, you may decide on different consolidation options, not only one. So it doesn't mean that if you decide to go to manage instances, everything is going to go to manage instances. Maybe some of your application will, and some others will go to Azure DB, some others are going to RDS. Maybe you're going to move from SQL Server to another data open source, so you need to have a plan. Assess the feasibility. So from the application perspective, is it feasible? From the isolation perspective, is it security, everything that we have discussed, is it even feasible? And my 2 cents, really depending on the complexity of your environment, I would recommend going step by step. So decide on a group of things that you want to consolidate, and then or move or reduce license cost or whatever you need to do, and just do it step by step, group by group. Okay, thinking also about the dependencies. Create a list of candidates, databases, instances by priority. So let's do this. Just an example. Let's say that you have 5 environments that are business critical, and the servers are on their knees. You need to buy a new hardware if you want the environment to perform better. So you are thinking, okay, what do I do? Maybe I will just move to the cloud, and then I'm getting rid of my performance issues. I don't have to buy bigger hardware. This is the right time. Another example is, okay, we're not in a rush. We want to consider moving to the cloud or doing another, reorg. So maybe let's start with databases with lower priority. So you decide what are the candidates of the databases and instances by the priority, and it could be the priority, could be anything, could be budget, could be performance, could be anything that is in your priority, and just start moving them slowly. Very important, proof of concept. Sometimes when especially when we're talking about legacy systems, you say, okay, I checked feasibility. Okay, I ran the upgrade advisor, and it told me that I can move from this SQL Server 2005 to this 2019. Okay, but you did not test, and apparently the application cannot move. So the database, yes, but the application not. So I really recommend to make sure that you do proof of concept, depending on the groups that you're moving, consolidating. Make sure that everything can work properly and you will not have a problem. So proof of concepts, 1, 2, or many. Another very, very important thing is to benchmark performance before and after. And why? So I've done a migration project or a migration to the cloud or upgrades, and the client came back and says, performance is not good now. It's worse than before. Okay, but it's not necessarily true. Maybe they have like part of the application that is not performing well because of something that is not related to the migration. So it's very important to benchmark the performance before and after so that you can compare in case something goes wrong. You can compare and you can understand what has happened. An example from a real client, they moved from a private cloud to the public cloud, and they got very bad performance. So when we were looking at the performance benchmark, we realized that they just got a machine that is less performant than the original one. Okay, so it's important. Always create a rollback plan. What if something goes wrong? Okay, because things will go wrong. So it could be a partial rollback or full rollback. Make sure that it's in your plan and you budget for it and you have the time for it. And let's talk about some helpful tools. I love free tools. There are also tools that are third-party that are not free. Let's talk about the ones that I think they're important for consolidation projects. So the first one is the map tool, the Microsoft Assessment and Planning tool. And just on a side note, Microsoft is still developing a lot of tools, because Microsoft and also the other cloud providers like Amazon too, they're developing tools because they want to attract customers to go to their overseas cloud platform or whatever platforms they are supporting, or it's their platforms. So, for example, Microsoft. They have new tools that you can use that will do the assessment and the migration to the cloud. Okay, so I'm going to talk about the ones that I know, but you need to be up to date because they're upgrading those tools even when we speak, because they want you to move to their cloud and they want to make it easier for you to do the entire assessment and TCO analysis and everything they want you to do. Okay, so map tool is an older tool. You have to install it somewhere in your environment. It needs to have a user with permissions, probably from Active Directory, with a lot of users on the different machines, and it just does an inventory search for you. Okay, so in most cases it will just be able to trace everything, but be careful because, as you can see, it also looks at the cloud, the desktop, just servers. So if you want to do SQL servers, you usually are going to do the inventory of servers and databases. Okay, and it still will give you some things that you don't need, but it creates an Excel sheet with all the information, and it also has like an internal database that you can back up and restore and do some analysis with the reports. It gives you the inventory, so how many SQL servers you have, and for each SQL Server instance, what's the server, what's the RAM, a lot of things like how many databases, database sizes, all kind of information just to give you an idea of your inventory. I had one client that they had different domains and different networks, different business units, and we had to install the map tool on each one of their domains. And apparently, because some of the servers were hidden on the network, the tool could not find everything. And those mostly were Express Edition. we've written some PowerShell script that goes and scans the Active Directory, and then for each server found on Active Directory, it goes and it looks for SQL Server services. That's also something that that can be used. But the map tool in most organizations will actually find everything for you. Okay, so inventory of everything that you have. Another one is the Microsoft Data Migration Assistant. So this is a tool that is the older version, and I will talk about the newer version. So this is also a tool that you need to download to your machine or anywhere on the network. And it helps you upgrading to modern data platform. It's detecting compatibility issues that can impact the database functionality. So this will be an error. For example, T-SQL that doesn't work in the newer version and stuff that are, so it has different levels of analysis, something that is really critical. And then it has recommendations for improvements. And then it also it gives you warnings where some of the features are not going to be supported in newer versions. And it's not only the assessment, it's also helping you move the schema, the data, and the uncontained objects from the source to the target. So it's actually helping you move the data with the structure. And this is SQL Server to SQL Server. So as you can see, we have specific sources, not SQL 2000, unfortunately, but it can move to SQL 2012 and as well as Azure. So what you do is that you say, okay, I would like to move this to this, and it will tell you, it will give you a report and will tell you what are the features that cannot be moved as they are. So you will decide what's the complexity of that migration upgrade. It's more upgrading. Okay, so it's less about consolidation, it's more about upgrading, but it's still a tool that we can use because we were talking about the feasibility of upgrade as part of the consolidation. Another one, and this I did not talk a lot about that, but if you want to move, let's say, to Azure or SQL Server from other data platforms, this is the tool to use, so SSMA. So you have to download a specific version for the platform that you would like to migrate from. So you will have SSMA for Oracle, SSMA for MySQL, SSMA for SAP. And then what it does is you connect to the source and the destination, and it will tell you how much effort you need. So it will tell you all the problems from data type perspective, from the code perspective. Let's take as an example Oracle. So Oracle store procedure, how easy it is to migrate them to SQL Server. Can it be automated? What's the portion of the store procedures or functions that cannot be migrated and need manual work, and it will estimate for you. From my experience, it estimates maybe 50% more than what I would have estimated myself if I do the manual estimation. It's a nice tool. It helps you migrate data. Another tool is the Microsoft Performance Analysis of Log, PAL. Okay, so this tool, you do have a lot of third-party tools that do performance analysis, but if you're looking for a free tool, what it does is that you can create a counter with Performance Monitor. Specific, like if you look at the documentation of the tool, it gives you the XML to create a counter. You run it for a while, and then you create a CSV file or a BLG file, and then you give it to the tool, and the tool analyzes, creates nice graphs, creates a nice HTML report. It's a nice report, but it's a heavy report. So sometimes you need to really understand what it gives you and how to analyze it. But for each one of the graphs, it will give you a description, like you see here, a description of what is the graph, what is giving you. Sometimes it talks about the expected values, and then it gives you summaries like average, maximum, minimum, and some recommendations. So for example, if you have problems with the disk, it will tell you that, let's say disk C has performance issues because blah, 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 and it will give you some explanation. So it's not perfect, but if you're looking for a free tool, you can use that for your performance and capacity analysis. Another tool, then this is something very, very recent, is the Azure Migrate. So Azure Migrate is part of Azure. So when you have a subscription on Azure, look for Azure Migrate, and it's like a hub where you can say, okay, listen, I would like to move to Azure, and this is what I would like to move to, and it assesses whatever you want to migrate to Azure on-prem, and then it gives you like it allows you to assess where to migrate and what are the sizes that you need on Azure, and it gives you like TCOs and all kind of things. Just a side note, Microsoft is still developing this. I presented last week at a different user group, and then somebody said, oh, it's not only from SQL Server or not only to SQL Server on Azure, also the tool allows you to migrate to Postgres. So but I played with the tool and I did not see that. So when you go, I did not play with the tool enough. This is I have a task at work to play with the tool and see what we can migrate from where and to what. But so I advise you to review the tool and see if this is something that is useful for you. On Azure, you also have ISVs with assessment and migration tools. So if you look at the Azure portal, for example, you will see that sometimes you see tools that are not Microsoft. So you can use them, and probably most of them you have to pay the vendors to use them. But for the migration, they can help you. But this one is free. The Azure Migrate is free. So it assesses the readiness, the sizing, the cost estimate, dependency analysis. Now, the dependency analysis I did see. What it does, it gives you dependency, not only databases, but also applications. So it takes for maybe the host name when it looks at the servers, and it tells you, okay, this is an application server querying from that database server. It's very nice, and it's a very nice user interface. And I think that the engine behind it was bought from a company, from another company, Movir, because Movir also allows you to do the same thing for the application stack. Okay, this is something that I did not talk about, but usually when organizations want to move to the cloud, they have to analyze the application stack as well, so it cannot be totally disconnected from the database stack. But we're database experts, so this is what we do, and this is what we talk about. So for the assessment itself, you have to, so Azure Migrate, this is something that I knew before. You had to install something, so it was not agentless. Right now, from what I read recently, they made it agentless, so you just run it, and it assesses everything without needing to install anything. Not even for the migration, but maybe for migrating from, in some scenarios, you will need to download an agent for the migration itself. So this is assessment and the migration itself. Okay, and this is for about Movir. Okay, so review the Azure Migrate. There's information about it, and it's still being developed. And my last one is the Azure Arc, which is still in preview, and it allows you to deploy Azure data services on any infrastructure and securely build and train machine learning models anywhere. Okay, so it chooses from a variety of Azure data services, and it provides you a report about what you can do. Okay, so for example, you can use Arc-enabled Postgres, Hyperscale. So Azure Arc is still in preview. I haven't played with this, but it will give you even more tools to do your analysis towards migration and upgrades and stuff like that. Okay, so I just put this here. I do not have experience with that yet. And the Azure Migrate gives you also the price calculations. And I know that Amazon has similar tools. But if you actually want to use the price calculators yourself, this is you have those two URLs, one for Azure and one for Amazon. So what you do is that it's a dashboard, and you can add the machines that you want, the size of the machine. You choose a machine, or you can choose storage. You can choose SQL Server, and you tell it that, am I bringing my own license, or do you have to calculate my license? It can be for a year or per month. Each one is different, and then you just have a dashboard, and you add everything that you want, and it gives you the price either per month or yearly price. And this is more for if you need to move few environments, specific environments, and you want to show management how much it will cost monthly or yearly, you can use those price calculators. And this is the public prices. So again, you need to talk to those vendors, because if, for example, you have any agreement with Microsoft or with Amazon, you may get better prices, really depending on the size of your environment. And quickly, let's talk about the case studies. So I talked about them during the presentation. So I was talking about database consolidation. When is a good idea to consolidate? When you have the same application, the same schema in the database, and you have too many databases, one per client. You want to consolidate few clients into one database. I'm not going to go through that. Next one is instance consolidation. So let's say that you have many instances. Let's say it's one per server. So we have a server and an instance, many of those, and they're hosting only few databases. So you're paying for either standard or enterprise edition, and you have only few databases. You may want to consolidate into the same instance. Hopefully they're the same version in addition, and you don't have to go through an upgrade. And let's assume that those databases, they don't have any isolation or security requirements that work. You cannot consolidate. By consolidating, you avoid a lot of maintenance and manageability, because you're consolidating everything, and you save license costs, obviously. And if you, let's say that you have 5 instances and you need to add now a high availability and disaster recovery. It's better if we are able to consolidate, and then the high availability and disaster recovery layer is going to be easier and cheaper. And then you have to decide if you're going cloud or on-prem. And this is about the database serverless. So as you can see on the Azure reports, you can see the activity of a serverless, and you will always be able to move from serverless to something else if this is not the right model. So let's assume that you started with serverless because your activity was, let's say, once a week or once a month, and then the database is becoming heavier, so you can move from serverless to another one. But serverless is really good. And this is an example with, you can go only up to 4 vCores right now with serverless. And you see this database is speaking at 80% of the vCores, but only really intermittently. So it's just speaking, and then it goes back to almost nothing. And this is the cost. So you can calculate, and even the price calculator can help you calculate how much it will cost you. In this case, it's $350 for a period of 24 hours. Okay, so why would I pay for a server for vCores if my server is almost idle? So this is just an example when you would choose the serverless over something else. And this is it for me. I hope I did not lose you. I did not check. Christian, are we still here?
No, I think yes.
Oh,
yes.
oh, okay, good, good.
Yeah,
So this is
absolutely.
so
I
you
was
did not interrupt
yeah.
me. I assume there's no questions. So this is
No
a
question.
good
You
time
were
to.
clear and lots of information. Thank you very much, Michelle. And people seems to like Synapse Analytics because it's MPP here. So we have a comment here from Denise Chamberlain.
Mhm.
So no, yeah, nice presentation, Michelle. Thank
Okay,
you very much.
thank you. Thank
Thank you.
you. So any question you can send to these email addresses
Address, yeah.
or to Christian.
If I can answer, right?
Yes,
Most important to
you
you.
will.
All right. Thank you, guys. Thank you.
Thank you. Thank you very much.